Okay, number 6 and 7, we have some trial probability here. We see that we have 1, 2, 3, 4, 5. 5 red out of 8. So the probability of red would be 5 out of 8. The probability of not being red will be 3 out of 8. Whenever we're doing trial probability, we're going to use this NCR, P to the R, Q to the M minus R. It's important to recognize, you see how these two values here, these two values are the same. These are both R's. This is different than the binomial expansion. So I like you to write your variables out if you can. It makes things a little neater. So we are spinning this 3 times. We care about 2 red. This is the probability of red. This is the probability of not red. So basically I'm just going to put it into the formula, type it in one shot, and if you use the fraction feature, it will return a nice fraction for you. You really should be expressing your probability as fractions. It's not a necessity, but it's recommended. If you did want to check this with the calculator key, you go into second vars, option A, which is binomial PDF, P for perfect, exact, perfect, and it's NPR, number of trials, probability of a success, number of successes. For number 7, it was a multi-step question. The first one was at least 2 out of 3 heads when tossing the coin 3 times. And you could see that they said it was a bias coin. Bias is bad. And the probability of heads would not be 1/2 but 3/4. So at least 2 is 2 or 3. And I always tell you, think money. Think money. 2 at least $2 is going to be $2 or $3, right? Just like we did before, we're going to set up a trial for each one, putting your variables over here on the side. Tossing it 3 times, we care about 2 heads. The probability of heads is 3/4. Probability of not heads is 1/4. Set that up. Again, these two match. Those two exponents match. These two always add up to the total of 3. So that's for case 2. It's 2 or 3, so or in probability means add. And this is for case 3. I'm going to type these into the calculator individually. That will show enough work. The first case gets me 27 over 64. The second case gets me 27 over 64, which is a probability of 27 over 32. You want to put this into the calculator. You do 1 minus binomial CDF, which is the option right under A, so I'm assuming it's B, N, P, R minus 1. So you're tossing it 3 times. Probability of success is 3/4. And the success number is 2 heads, so it's 2 minus 1. So I always say that it's symmetrical on the ends here. Type in the calculator, you get the decimal equivalent of this fraction, which you can convert to a fraction. Second part, that is an at most case. At most case is 1 or 0. Here is the case for 1. And here is the case for 0. I type them individually into the calculator. Sorry about that background of that book. And I get my 9 over 16 and my 1 over 64, which gives me 37 over 64. So let's talk about the calculator key for that one. That's straight up binomial CDF, and you can see the difference. This is binomial CDF, just NPR, and with the at least case, it required a little bit more work with the at least case. This calculator key is much more friendly with the at most case. Let's put that in and see if you get the right answer.